Hi all, welcome to today's session, and today we are going to discuss about the vault setup, and we are going to install the vault on the Vagrant from the scratch itself. And then we are going to discuss about the various configurations that we can do for the setup of the vault. I am your host Ankit Mittal, and let's start. So I have already installed the Vagrant on my Windows operating system. You can refer to our previous video on the Vagrant installation for more details. For now, I am inside my HashiCorp folder and projects. If I do a dir, I can see I have already created a directory for Vault. And if I again run a dir, I can see the Vagrant file is already there. So I can directly run Vagrant up, and this should start our machine. So I'm just quickly going to pause and start back again once the machine comes up. So at this point the Vagrant has completed running and it has already started the machine, and it's forwarding a port 22 to 2222. So I need to connect on my local host IP, that is 127.0.0.1. That's my loopback IP on port 2222. This would get me connected to the VM. So I'm going to use the username Vagrant, and it was not able to use my previous key, so it has actually replaced that key with a new key, and I can run the command vagrant ssh-config to check the details of the new key. Once done, I need to use the putty to connect to my virtual machine. So I'm just going to connect or use the puttygen to create a ppk file which can be used by the putty, and then I'm going to log into the virtual machine. So at this point I have provided all the details for my virtual machine, that is Vagrant, at my loopback IP. The port I have provided, and I have generated a ppk file for my Vault project, and I'm going to use this ppk file to connect to my virtual machine. Now I am going to save this as a Vagrant session, okay, so that I can, if needed, I can directly click on it and connect to it. So I'm just going to click on the Vagrant, and it shows a warning to me, okay, for matching my fingerprint. So I'm just going to click yes, and at this point I am connected to my virtual machine that I just created using the VirtualBox. So I have connected to my virtual machine, and I can take on the sudo, okay, and if I check the if config, it's getting this IP. This is bridge between my host and this virtual machine, and if I run read-m, it's going to show me how much memory has been allocated. So I am currently using 4 GB memory allocated to this virtual machine, although you can use about 1 GB or so in case you are just going to test this out, and the production system needs to take into consideration for the high availability. So currently we are going to start by downloading the HashiCorp. So I'm just going to move quickly to my optional opt directory, and I'm going to directly download the binary from the HashiCorp. The latest release version at the time of creation of this video is 11.1. So I'm just going to download the zip binary from the HashiCorp website, and this will connect and download the Vault 0.11.1 version. Once downloaded, we are going to unzip the Vault zip binary. It's taking a few seconds. Okay, so Vault has completed downloading and the Vault is downloaded now. Okay, so if I run an ls, I can see the file has been downloaded, and I can unzip this zip file. Okay, run unzip. Also, unzip is not installed. I'm quickly going to install the unzip. Alright, unzip has been installed, and I'm just going to unzip this file. And if I run an ls now, I can see the Vault folder has been created. So at this time, this is basically a Vault binary. If I run this, it's basically a file, so I can directly copy this binary into the USR bin, so that it's available for directly executing over my command line. I can directly reference to it. Once done, I will be creating a vault config directory under the etc and a data directory as well as a log. So I'm going to create the three directories, one under the etc, another one for storing the vault data, and third one for configuring the logs. So start by creating a directory for vault, etc vault. Okay, then create a directory slash vault hyphen data. You can create a separate mount for vault data in the production system if required. Also create a log directory for vault logs. Okay, so I can directly create this like var log vault. Okay, so at this point we have created the three directories, and this would be used for storing the configuration data as well as the logs for the vault. Next we are going to create a config.json, and we are going to add the configuration for our vault in this config.json file. Okay, so use start by creating config.json. So now within the config.json, start by entering the JSON data. Okay, so we'll make an entry for listener, and I'm quickly going to type all in the configuration so that you can look into the more configuration and understand the details, like it makes a TCP connection for resolving the address over the port, so it can receive the request from any host within the system over the port 8200. We are going to disable the TLS for now. Then we are going to provide the API address. HTTP. We need to provide the IP over here, so I'm just going to write an IP 8200 and quickly going to update the IP shortly over here. Okay, and Then I need to provide the storage. Max lease TTL. This is the maximum lease time. So maximum lease time for an API, we are going to keep it 10 hours by default. And there would be a default underscore lease TTL. That would also be a 10 hours by default. We are going to keep the UI to be true if you want to use, otherwise you can keep it as false as well in your production systems. And that's it for now. We have written down the configuration for the vault, okay. And now max underscore TTL, we have, although we have kept it like 10 hours, this is only for the development environments. If you are doing it for a production environment, so the API is actually respond to in a much more quicker way in a production environment. By default, within the API has to respond within a time period of 60 seconds. That's also very high. So you would see normally it's less than 1 seconds or few seconds. So depending on this, it's you can keep something like 30 seconds or 1 hour, depending upon the maximum lease of the TTL that you want to give for an API request for the authentications. Okay. And now this configuration holds true in the case of your file system, and in case if you are doing it on console, or you are running a console, or you are running some cloud backend service such as your AWS S3 or your GCS backend, like GCS bucket. In that case, there is an additional, you can specify the storage configuration over here, which would actually respond to the console or your GCS, that is your Google storage. And since we are going to keep it by default on the file system, so we will keep it like this only, though I can show you for the reference over here how you can do it. I'm just going to put on the comments over here. So I'm just going to quickly show you how you can create the console configuration or your GCS configuration, that is Google storage. Okay, so start by defining the storage. You need to define the address over here. Let's say if it's running locally, then you can use the loopback IP for the console, and it runs over port 8500 by default. If you use some other port, then you need to specify that. Specify the path. Let's say we created something called a service like vault. Path is vault in this case. Or it's showing red because it's not able to locate it, because the console we haven't installed the console. This is just for the reference part. I will going to delete this configuration once I have showed you the example, or you can specify the storage similarly for the GCS as well. In this case, we are going to specify that the storage is used as GCS. Okay, and we are going to specify the bucket. This is for the GCS or the Amazon S3. It holds good even in case you are using the AWS S3. So we can say that let the bucket name can be something like vault storage. Okay, and once done, HA underscore enabled. Whether you want to enable the HA for it, I can mention something like and that's it. At this point, this is how you can specify the storage in case you are using the console or the GCS backend. For now, we are just going to remove this because we are not using the console or the GCS. Alright, that's it, and we are going to save it, come out of it. I'm going to run, I'm just going to clear my screen. I'm going to run if config, get the IP, and my IP is 10.02.15. Okay, so I can copy it 10.02.15 and I can go back and enter the same. And 15. Okay, this completes my configuration, and I will clear the screen. At this point, we have created the configuration for the vault. Okay, and next we are going to create a vault service. So let's start by creating a vault service so that we are able to start and stop the vault. Okay, so this is Ubuntu 16, that's Ubuntu Xenial, so we are going to create it in the systemd. Okay, and go to etc systemd system vault.service. Okay, under the vault.service, create a service file. So I'm just going to quickly type in here the vault service. I'm going to specify the unit and specify a description such as this is a service was target. So I have specified a condition so that in case we are using some configuration management tool or some other tool to automate this installation, then if this config.json that we just created above is not present, then this service shouldn't be started. Okay, otherwise it's going to error out. So that's like a flag for us, and we have set up a condition that the file must exist. Then we can start by specifying the service. Go max process. This is basically we want to keep it like 2. We don't want to go above 2. In case it fails, try to restart it. Okay, on failure, that's the start command that we are going to specify. Since we already copied the binary in the usr bin, go ahead, usr bin vault server hyphen config etc vault json. We are going to specify the standard that we want to receive. That should go in var log volt output.log. Okay, we are going to give the standard error as well, and the standard error will go to var log error.log, and we are going to specify limit the memory as well. Limit log, and we are going to specify, so we are not specifying any memory locking for this process. Okay, and include $man mean PID signal should be zip down, and then lastly we are going to specify the install by user.app. Okay, so this creates the service file for the vault. Save this, and at this point we can start the vault service using the systemctl start vault service. So something seems missing. Let's see. Okay. See the logs. We can run journalctl.exe for details. Alright, so just let's quickly try to start this manually and see what happens. Seems like some permission issue would be there. Okay, so I'm just going to run this manually to quickly check what went wrong. So this is actually starting the service. So I'm just going to turn it down. Okay, it doesn't stop. So I believe there's some problem with our system. The service that we just written down might be some error or something. This just hyphen over here, and this seems to be good for now. Alright, since we missed a hyphen, let's try and start again. Okay, at this time this is successfully started, so we missed a hyphen due to which it was failing. We saw how we can troubleshoot this out in case the vault service gets failed. We can try to manually start it. At this point, this confirms the service is running actively, and daemon would be trying to restart in case it fails. Okay, at this point we have successfully installed the vault and started the vault service, and we are going to enable this vault service in case the system restarts. So let's enable the vault service. Alright, so vault is enabled now. If I run the next at -2 so I will see that it's listening on the port 8200. Okay, and this confirms that the vault has been started and listening on the port 8200. Now, and we can export this into the browser as well, and address on the port 8200. Okay, and something like this, or 10.02.15. okay, so we can run export vault underscore address in http 10.02.15 colon. I just verify it. 10.02.15 5200. Okay, and I can export the same, update the same, export http 10.02.15 to my bash rc file. Okay, I can run the vault status. And this would actually give me an error because it's right now sealed, and this is the default behavior of the vault. Okay, So it would not allow me to make an API request right now because by default it has initialized and the vault starts in a seed mode. So let's initiate the vault server and store the initial tokens in a file. Okay, that way we will be able to log in. Okay, so we are going to execute the command like vault operator connect. Okay, and redirect this to etc vault init file. Okay, once you do that, now the status, again vault status, and at this point it shows that the seed type it's using is Shamil, and it's currently set to true. Okay, so it's sealed. Now, if since the vault is currently sealed, so we need to unseal it. And for unsealing it, vault will provide us with some of the tokens, and we need to use those tokens to unseal our vault. Okay, for unsealing the for these tokens, you need to open the init file that we just created using the root user. Okay, and these are the steps for unsealing the vault. Otherwise, you won't be able to access the vault by default like that. It doesn't create any default tokens for you to access. Okay, just run this, and this actually shows the unsealed keys. Okay, these are the keys through which can be used to unseal, and here is a root token as well, which you can use. Okay, and it provides up to 5 key shares basically by default. So now, once the vault is unsealed, it will remain unsealed until one of the two things happens. Okay, it is resealed via the API, or if the vault service gets restarted, or during a server restart. So you can unseal a vault using the unseal command. There are 5 unsealed tokens that are provided to us. Okay, and we need to use the unseal command with basically at least three keys. Okay, as it shows, it uses a seal type called shamir. Okay, we are going to cover this more during the architecture of vault. You would see that shamir by default creates 5 shares and at least required 3 shares. This increases the integrity of security built in within the vault. Okay, so use at least we will need to use 3 tokens to unseal the vault. Okay, so quickly copy this. I will copy this keys. Okay, alright, so I have copied down the keys, and then I'm going to unseal this vault. Okay, alright, you can unseal the vault like vault operator unseal provided by the key. Okay, so at least 3 keys needs to be provided like this. Okay, here now we can see that on a standalone vault, okay, this should be up now. Let's run the vault status. Okay, so it's showing now the previously it was showing that it was sealed. Okay, now this shows that the it's no longer sealed because we have already provided the 3 tokens, and when we run the vault status it shows that it is unsealed now. Okay, and sealed status is to be false, and also this is basically a standalone vault is up and running successfully. Okay, and we can start by enabling the authentication method and secret engine, uh, which we like. Okay, so we can at this point we can open the UI as well. At this point, we have successfully installed the vault. We have unsealed the vault. We are having the tokens which can be used for unsealing and access the vault. Okay. Now, at this point, you can access the vault using at the port 8200/UI, and access login with the root credentials using one of the tokens that we just created. Further, you can go ahead assign the roles and policies, which we are not going to cover in this session, but in a later session we are going to cover that as well. Okay, so kindly subscribe to our channel to remain updated, and we will be sharing the login to the vault UI and configuring of the rules and policies in our later session. Thanks. This was your host Ankit, and that's all for the vault session. Thanks for watching.